Okay, in this section we're going to learn how to apply some inequalities, and we're just going to be able to have to read these word problems and set them up as a math equation. And so let's just write one down here. What if we say the sum of 3 consecutive integers is more than 20. Okay, so what are the values for these 3 integers? All right, for them to be consecutive integers, so just think if we were reading the pages of a book or something like that, and we have, if one page is 10, the next page is going to be 11, and then the next page would be 12. Well, how do we get to those? The problem is you don't know the first one. So the first integer is going to just be x. Well, then how do I get to the second integer if it's the next one in line, like 10 and then 11? Well, it's going to be x plus 1. My third integer, then, well, if I had 10, 11, and 12, so the original one would have been 10. In order to get to 12, that's x plus 2. So you see how those go in order. And when it says the sum of them, that means we're going to add them all together. And it should be is more than 20. Well, more than means greater than, right? So let's add up all of our integers. So here's the first one, plus the second one, which is that x plus 1, plus the third integer, which is x plus 2, greater than 20. Okay, well, we know that we have to combine like terms on both sides before we can start solving for an equation. So I'm going to combine these x's, and I have 3 of them. So that's 3x plus then my whole numbers, 1 plus 2 is 3, is greater than 20. So now I can start solving. So just make sure you don't, if you can only change the signs if you cross the line, which is that equal sign or the inequality sign. If we're on the same side, we're combining like terms, and we do not change any of those signs. So from there, we just start solving. We're going to subtract 3 from each side. We get 3x is greater than 17. And then we're dividing by 3 on both sides, which didn't come out very pretty. So x is greater than 17 thirds. Well, that's not a very pretty example. So it's got to be, which is 5 2/3. Same thing as that. So then the smallest possible value for that integer would have to be something greater than that. So x would have to be greater than 5 2/3, and I just converted the 17 thirds. So then probably the smallest one would be x could be 6, x plus 1 would be 7, and x plus 2 would be 8. So those would be your 3 integers that would be more than 20, and those would be the smallest ones. Anything above that then would also work. So that's that one example. Let's look at another one. What if we say 4 more than a number is at most 84. Okay, well, this part's sort of easy to get. 4 more than a number. 4 more than something would just be x plus 4. But what does it mean is at most? At most means that's 84 is the maximum number that it could be. So 84, then would have, x plus 4 would have to be less than, but it could also be equal to, because it's at most 84. So x plus 4 is less than or equal to 84. So we would just subtract our 4. So then x would be less than or equal to 80. And these are just, I always say when we're doing word problems to always try to find out where's the equal sign or where's that inequality sign at, and then try to go from there, like look at each side of the equation and decide, okay, well, what's going on the left-hand side of that equal sign in our words, or the inequality part of our words, and then what's going on the right-hand side of that to solve for these. This could help if you are wanting to get a job and you know that, well, I need to at least $50 a week in order to, pay some bill that, my cell phone bill or something like that. Well, then and I can work 10 hours. Well, you can set that up as an equation and solve for that to see how many hours you would need to work for that. So that's how you do these inequality ones. And I don't think I gave you too many on your homework, so just so you to have a little bit of practice on that.